Arctica is a free and open source multi-signature self-custody Bitcoin storage protocol that makes use of mini-script descriptors and that foregoes hardware wallets in favor of generic hardware such as USB sticks or SD cards. Each USB stick runs its own self-contained operating system and contains a copy of the Arctica software. Additionally, each SD card contains an encrypted tarball which has been encrypted with GPG and provides optimized security and privacy by encrypting both the keys that correspond to the wallet and the wallet files themselves, as well as the miniscript descriptors that are associated with the wallets. This not only provides physical security for the actual signing keys, but also security for private information such as descriptors, which contain things like transaction history on the associated wallets. These USB sticks are set up automatically by the Arctica software, and very little input is required from the user to get these USB sticks set up in the way that they are now. SD1 is the primary card. It's what's used for generating transactions, and it's the one that you will primarily have plugged into your full node computer. SD1 is a hotkey. Should the user ever lose access to SD1 and its corresponding backup CDs, any other SD card can take its place with a simple configuration file change. The other 6 cards are offline signing cards, and these cards can be booted on any device as they disable networking on that device when the software boots, and can be used to sign a partially signed Bitcoin transaction from any computer capable of booting from USB. Additionally, all of the important information such as the private keys, public keys, and descriptors on each SD card is also backed up in its encrypted form on a separate CD and DVD. This means that the user is not required to handwrite any seed words, backup phrases, or descriptor policies. This makes for a very seamless user experience when it comes to receiving and sending Bitcoin. I will now demonstrate the user experience flow for spending from the 2 of 7 multi-signature wallet included in Arctica. Please bear in mind that Arctica is still in early alpha and there are many missing or broken features, and I currently do not recommend that you utilize this software for the storage of any meaningful amount of money, as updates will continue to come that will improve the usability and the security of the product. Additionally, I would like to point out that the login feature currently requires that the user manually obtain 5 decryption shards from 5 of the various SD cards and reconstitute them into a master decryption key. This process can be handled by the software, however, it is cumbersome, and I do intend at some point in the future to allow users to log into their decrypted tarball using a simple password and a blind pin server. But that feature is not yet available, so here you will see me logging in with a login CD which I have already created previously. I will now insert a blank CD, which the software will automatically burn the PSBT which I've just generated onto, and will be used as a medium to securely transfer the PSBT to whatever device I boot my next SD card on, which I wish to use to sign the PSBT. Remember, each of the 7 SD cards is its own private key, and any of them can be used to sign this transaction. I would also like to quickly point out now that all privacy and security sensitive material is only handled in volatile memory within a special section of the computer that I've created in the temporary file system within RAM disk. So anytime the private keys or descriptors or wallet files are decrypted, they are handled only with volatile memory and are never written to disks so that they do not leak privacy or security sensitive material. I will now be powering off this machine, which is running an instance of Bitcoin Core started by Arctica and being used as the full node backend for the software. For the purposes of this, I'm demonstrating what it looks like to use Arctica with your node machine as your signing device. However, one could prevent the time required to restart and sync the blockchain on SD1 by simply using a secondary computer as a signing device for SD 2 through 7, and from a security perspective, I would actually recommend this. But it's important to note that any SD card can theoretically be securely booted from any machine because of its own self-contained operating system. For the remainder of this video, I will fast forward through loading screens and only stop to talk when I deem something necessary to explain. We now have a fully signed and ready to broadcast 2 of 7 Bitcoin transaction, which will be sent as soon as I click the button to approve its broadcast. Please excuse any clunky UI or bad styling or bugs you might have noticed in this video. These are all things that I'm taking note of and excited to improve upon over the coming months.